So apparently, if you shake a magnet, light comes out. Let me explain. So this all came from an idea that if photons are the mediator particles of the electromagnetic force, then are magnetic fields made of photons? And therefore, do magnets produce light? So I started investigating, and the answer to the first question turned out to be kind of. Because magnetic fields are really just the range of the magnetic force exerted by a magnetic object, like our magnet. And photons mediate any magnetic interaction with that object. So it's not really that they make up the magnetic field, but rather they mediate any interactions with it. Oh, by the way, I explained magnets in detail in a previous episode, link in the description. Anyway, so the answer to the second question is all the more interesting, because it turns out if you wave around a magnetic field, real, so non-virtual, photons will come out of it. But why? Well, it's because when you move a magnet, the magnetic field changes. And as these changes don't propagate instantaneously, but at the speed of light, this produces waves. According to Maxwell's equations, a change in a magnetic field produces an electric field, and an interplay between these two fields manifests as an electromagnetic wave, a photon. You might have seen this representation before, peaks in one field aligned with drops in the other, and this is a photon. Also, magnets move electrons and contain electrons and protons themselves, and any accelerated charge generates photons, although this effect is tiny. Well, tinier. So I decided to test this out experimentally. This is a 22,000 RPM 12-volt motor, and this is quite a strong neodymium magnet. And with this little contraption, I'm going to make the magnet spin super fast, and my phone camera, which is supposed to be able to detect even some infrared wavelengths, we should be able to see some light come out of the magnet in theory. So lights off, please. And we're gonna turn it on in 3, 2, 1. So that thing at the beginning was just a spark. I don't know what that happened. But as you can see, no light really came out of the magnet. So, am I lying to you? Well, no, because as always, there's a catch. As the electromagnetic waves move at the speed of light, the equation for their wavelength would be this, where lambda is the wavelength, c is the speed of light, and f is the frequency of movement. So we substitute the constant, we put in the frequency of our motor, but instead of revolutions per minute, it's revolutions per second, which would be hertz, and this gives us about 366 hertz, and we get that the wavelength of our light is around 888,181 meters. For comparison, look at this light spectrum diagram. The longest visible light wavelength, which is red, is about 750 nanometers. Well, let's go a bit further. Infrared? Nope, still just 1 millimeter. Microwave? 30 centimeters at most. Well, but what about radio waves? Oh, right, that's just literally the rest of the spectrum. But the radio wavelength you use in your car is a few meters long at most. Our wavelength would fall in the longer edge of the ultra-low frequency part of the spectrum. And in fact, we can rearrange the equation to calculate how fast we'd need to spin our magnet to be able to see its light. So c divided by 750 nanometers, or 0.0000075 meters, gives us a frequency of 400 terahertz. And this, in revolutions per minute, is 24 quadrillion RPM. For perspective, the fastest spinning space object ever recorded, a pulsar with a really weird name, reaches only 43,000 RPM. And the fastest spinning object ever done experimentally, which is actually microscopic, which would kind of be cheating, is only 300 billion RPM. Like this is huge! So then, is there any use whatsoever to what I've just told you? Well, I'm glad you asked, because there is. MRI machines use protons, which being so small can spin super fast, and make them resonate at about 128 megahertz to produce a low frequency light which can be used to analyze the internal human anatomy. So thanks for watching. I hope you enjoyed the video. Personally, I think this is such an amazing phenomenon. If you have any ideas for future videos, you can leave them down in the comments. And as always, please like and subscribe, and I'll see you in the next video. Bye!